Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super. Mike, I'm going to kick it off with you. So it started off as a cooling event due to a power sag, but this had a very long duration. Can you talk to us about what happened and why it took so long to recover?
Sure, Sami, thank you. So on the 7th of February at approximately 15:17 UTC, the whole Isle of Singapore saw a power sag. It ranged between 130 milliseconds and 50 milliseconds, and then the sag rate was anywhere between 40% and 55-ish%. When that sag hit our equipment, as expected, the servers, they rode through no issues. UPSs picked in, carried the load. Some of our cooling equipment rode through with no issues. However, there was impact. We saw impact at 4 chillers within one data center. The team on site worked to do rounds to check the equipment and attempt to bring up those 4 impacted chillers. But at around 16:30 UTC, we started to see temperatures rise in our data centers. This data center is 4 stories, so we have people going up and down, checking, servers, checking rooms, working on equipment. And they continued to work to restore cooling. However, they weren't seeing much success. We have a thermal buffer tank, which will supply cold water into the system or inject it into the system in attempts to carry us through. However, at around 1800 UTC, or roughly 3 hours after the SAG event, we started to see temperatures rise into the 40s and 50 centigrade. At around 2019, that's when we made the call to turn down or start turning down racks proactively. By 2030, we had made the call to shed load across all 4 floors in attempts to stabilize cooling. This is shutting down storage. This is shutting down Exchange. This is shedding some compute load. Now, storage isn't our normal go-to thing to turn off. I'll let Tom talk about that here in a minute. Over the course of the next probably 10-ish hours, we were in contact with the OEMs, the equipment manufacturers. We were working with them to troubleshoot what had happened to these chillers and bring them back online. We're working with the various teams here in Microsoft to either stabilize or see what we can do to shed load, because we were unable to stop this thermal event. We were able to stop it from increasing, but we were unable to keep it at a usable temperature for our services. The teams worked through the event, talking to chillers, working on resets, trying to bypass some of the logic within the systems. And then at approximately, what would it be? Sorry, I got a 11:30 UTC on the 8th, we were able to recover some of the chillers. And as we brought the chillers back online, we were then able to start introducing the server load and bringing it back online. We, of course, started with what we shut off first, the original clusters, and then worked our way through compute, Exchange, the GPU services that are in the region. This event took approximately 24 hours to get recovery back to the services, and then longer once the services got power back to the racks. Gonna hand it back to you, Sam.
Right. Yeah, that sounds like a really good summary of at least what happened in the data center in terms of the cooling, the chiller units, trying to get things back online. Now you mentioned Tom, so I'll hand over to Tom from storage to talk to us. Storage underpins everything. So obviously all of our different Azure services, they use some kind of storage. So could you help us to understand why storage were amongst the first kind of racks to be powered down and what this looked like from a storage perspective for the recovery?
Sure. So as Mike mentioned, we kind of made the decision to proactively shut down some of our storage capacity. We shut down several what we call storage scale units. A storage scale unit is a set of storage nodes across some set of racks. And in this case, we shut down standard storage scale units. So that would have impacted standard disks, blob, tables, queues, and so on running on that hardware. It was a very tough decision because we were basically deciding, okay, we're going to shut down these clusters that right now are working, on scale units that are right now are working okay. And the reason we did that is based on our past experience with kind of temperature excursions. We know that if we allow the hardware to run beyond certain points, certain temperature points, we can start to have some level of hardware damage and failure, and that can lead to very, very long recoveries. So sometimes days, if it's a big, we've had one very bad event in the past, and we learned the hard way that it will take us much longer to bring things back online if we don't shut down the equipment to protect it before temperatures kind of reach critical point for that hardware. So it's a very difficult decision. We made it based on monitoring our server level temperature thresholds, and when we felt that things were reaching a point where it was going to cause problems later, we made the hard call to shut down those scale units. Now, the good thing is that it all came back up fine. We had no issues with storage coming back up once the cooling and power was restored. So it turned out to be absolutely the right decision compared to some outages we've had in the past where we weren't so proactive with shutting down hardware.
Super, thank you very much. So I'm going to turn it over to you, Brendan, next one on my left. So you run our management and governance team, and you're also responsible for ARM, which is Azure Resource Manager. Now, from what I know, ARM is responsible for every control plane operation. So if I create a VM, if I destroy a VM, if I scale it up, scale it down. ARM is also a global service, and as a global service, customers should expect you to be resilient to this type of outage. It's one part of zone in one region, but ARM struggled in this one. Could you tell us more about it?
Sure. As you mentioned, ARM is a global service, which means we actually have a presence in every single Azure data center. And in fact, we actually also have replicated data in all of those different Azure data centers. And so when this incident started, what we started to see was problems with people who were sending traffic into the Southeast Asia data center, as you would expect, because the incident was happening in that data center. Now, unfortunately, due to a configuration problem, our storage in that region wasn't zonally resilient at the time, which meant that we had to drain traffic out of the region, out of Southeast Asia. Our VMs actually were still operating correctly, and sort of in a fog of war decision, we made the decision to drain all traffic away from Southeast Asia instead of simply redirecting the VMs that were in Southeast Asia to storage in a different location. If we had simply switched the primary location for the servers that were running in Southeast Asia, we actually would have rode out Southeast Asia using the other zones that were unaffected by this particular outage. Once we made the decision to remove Southeast Asia from our rotation, we use DNS-based load balancing. And so the result of that is that when the Southeast Asia region is removed, the next time you look up management.azure.com, if you were in that geographic region, you were directed to our East Asia data center. Now, it turns out that East Asia is typically a relatively lightly loaded data center. And so we were scaled down somewhat small in that data center. And so when all of the traffic that had previously been headed to the Southeast Asia data center suddenly got redirected to go to the East Asia data center, it overwhelmed the servers that were there. And this sort of leads to the second issue that we saw, which was that as our DRIs went to scale up in East Asia, they actually discovered that we didn't have sufficient quota in East Asia for our particular subscriptions to scale up to handle the excess load. And so we had to actually go through the standard Azure quota process to obtain more quota so that we could actually scale up ARM in East Asia. It's worth saying that the impact on East Asia was more of a degradation than an outage. At the worst, we saw somewhere between 80 and 85% availability for ARM, but it still has a pretty significant impact on customer experience, whether it's via the Azure portal or automation services that are in fact making ARM calls to create or to remove VMs from Azure or any other kind of resource from Azure. And so generally speaking, people who are using ARM throughout the rest of the world were not affected by this particular outage, but anyone who is routed into either Southeast Asia or East Asia during this time was affected by the outage. And that includes a number of Azure services that are in those regions doing things on behalf of customers, because they, of course, talk to that local ARM as well.
Great, thank you, Brendan. That's helpful to understand, because I think some customers were surprised in the post-incident review when they saw East Asia. That kind of helps us to understand how it was able to expand beyond Southeast Asia. A question for Amy, who's dialing in remotely here when it comes to SQL. Now, like storage, SQL underpins a lot of our Azure services, but it sounds like different SQL customers experience this outage very differently. So Amy, I wonder if you could talk us through, some SQL customers didn't experience any pain at all. Other customers saw some extended recovery. Could you help us to understand why different SQL customers experience this outage quite differently?
Absolutely. So like you said, some customers who had AutoDR configured, or they have zone redundant offering, they have very little impact or zero impact. But unfortunately, there are still three different kinds of impact that customer did experience, and some of them actually had very extended outage. So the first kind of impact that customer had was that they did configure failover group, and then they did ask us to do auto failover. So for those customers, they had about 1.5 hours of downtime. And then we also did auto failback for them when the whole data center problem was mitigated. In the process, we did respect data residency, because that was a question that did come up later. But in this particular category, right, we did have some learnings. One is that it did take 1.5 hours for us to evaluate whether we should do automated failover for all the customers who have configured that. In the future, we want to do this faster. We want to do this in a more automated fashion. And the second one is that we do want the customer to actually decide. Because when you do a failover, you actually have the graceful failover that you don't have data loss, or you do a forced failover, and then you might incur data loss. We want customers to decide when they are setting the failover group, whether they want to prefer availability over data loss, right? Not at outage time, because then you have, again, the fog of war. So then give customers also the clarity at that time when they want to choose, is this going to be graceful or not? Are you going to have data loss? And then if you do have data loss, because you have to failover to have availability, and then to help them to be able to recover that lost data as well. And also just in general, better document the process, how we do auto failover, auto fallback, because we did get some questions about the process in general. The second type of customer impact that we saw were actually zone redundant customers. Most of customers who had zone redundant offering, they had zero impact. But unfortunately, for the customer who were using proxy connect mode, they had some impact. So kind of just as setting some context. For connection, customers have two options, is redirect or proxy. For most customers, redirect is a preferred and default mode. But for private customers, proxy connection mode is a default until the redirect mode is going to be GA. So in this case, why did the proxy private customer who had a zone redundant offering actually had impact? They couldn't log in. So the problem was the proxy connection is pretty expensive. So we have a throttle in our gateway component. So in order to not overwhelm gateway when you have a lot of very expensive proxy connections, we kind of keep a limit on how many connections we have. So when a lot of the databases went down, right, they keep trying to reconnect. So that created more connections. So this ended up clogging up the queues. And then the valid ones that couldn't go through as well. So that created a problem, kind of just block everybody. So the learning for us here, obviously, is that we need to fail fast when we see this kind of problem. And then to be able to engage and distinguish the good ones and then the bad ones. The good ones they just will not be able to cover, but the ones that are on zone redundant offering, they actually should be able to get through. So that's additional, data like metrics that we need to collect to be able to make that distinction, to be able to tell when we are hitting the proxy mode throttle, when we are seeing the login successful rate drop. And then the other one is, we need to be able to simulate this kind of zone down scenario. to be able to simulate this kind of proxy traffic, this kind of a load. And this will help us uncover this kind of scenarios that usually we didn't find in our normal zone down zero. So then, we'll come down to last one, which is there is one single cluster out of everything that went down that took a very long time to recover. And the reason is that that single cluster had some nodes that didn't come up. They were actually stuck in the BIOS prompt. And after the nodes come up, SQL runs on Service Fabric. And Service Fabric for that cluster failed to reform. And the reason was that Service Fabric had, similar to our gateway, also had a limit to how many threads you can have. It's all the self-protection, right, to avoid sometimes a lot of the disaster scenarios. So when the nodes were booting up, especially in the timing that they were coming up, especially some of them came up later because of the BIOS, the problems that were hitting them, then the Service Fabric for that particular cluster hit thread exhaustion. So then it was trying to come up and go down, and then couldn't come up in time. Half of the nodes rebooted automatically, but half of them didn't. So all this basically created a race condition that we didn't know before in Service Fabric because of the spike and then throttle and then become a deadlock. So we definitely have some interesting learning for this one as well. Similar to the previous one, the drill that we do, right? Do it with full load. Do it with simulation of the different things can go down at different time and the sort of race condition they can create for each other. And then for Service Fabric, the throttle that was put in place that we have seen for this particular place should have been higher, right? If the throttle was higher, you would have allowed the threads to go through when all the nodes were coming up, and then the Service Fabric cluster would have been able to reform. And other things, Service Fabric should be able to monitor and self-recover if it's stuck in such a throttling state as well. So those are some of our key learnings for all the impacts that we have seen customers.
Super. Thank you very much indeed for the insight. I'm going to turn my attention to Eunice. Eunice, what problem with customers that zones can go down, and we have documentation and BCDR exercises, but surely in this case the impact was it was more disproportionate than taking down part of one data center. Did our zone strategy work? Did it work as designed, or is there a gap somewhere?
Absolutely, great question, Sami. Availability zones are essential to the availability and resiliency story of Azure, right? There's no doubt about that, right? So this outage was really eye-opening. It was a little bit unfortunate in amount of impact that it had. But I want to reiterate that availability zones are really key to a strategy for Azure to be available in case of failures like this. While a large number of services were impacted, and you heard all of my colleagues talk about those, and a number of other services were also not impacted. I just want to call that out. Many of the foundational services kept working. Those names did not come out because they were not impacted. Just means to say that we have been building to the availability zones, but we need to do better, clearly. There are a lot of learnings here. So I just want to go over some of those cross-team learnings that we are putting into motion, that we have already put into motion. Some of them, they're in progress. I just want to go over those a little bit, right? The first of those is to do a thorough review of all the foundational services to see if there are any gaps in the resiliency profile, if there are any gaps in the dependencies that they're using, or the dependencies of the dependencies, basically walk the dependency graph and see that for our Azure services, there aren't any elements of weaknesses in their build out that would make them vulnerable to incidents like this. So that's a review that we have started, already done it for a few services. That's going every day. In fact, we have daily reviews going on. We are filing repair items. We're filing against the teams, and the teams are working actively on this. Is like priority 0 for the teams to go fix this, right? So that's happening. So that's number one. And number two is we need to catch these gaps before they actually happen in production. Now, to be clear, we have validation, ongoing validation. We do DR drills, what we call DR drills in our Canary environment, which is a pre-production environment, and routinely validate a number of scenarios there for resiliency, but we have missed quite a few, it's clear. So we are increasing the coverage there to cover more services and more scenarios of those services to make sure that that we can catch this on an ongoing basis. Because, Sami, I mean, you can have a service in a good state, but then, engineers make check-ins every day, and that can cause regressions, right? So we want to be able to continuously validating this scenario, just like we validate for functional scenarios. We want to validate for the resiliency scenarios on a continuous basis, so that we are not leaving gaps like this when the services ship out there, right? So that's a second very key element of this. One of the things that we also saw kind of hit bumps in this recovery in Singapore is the DR, right? The DR, the disaster recovery, which is basically about where you take the state and have it in a different zone or a different region and then rehydrate the service instance there. That ran into some gaps in terms of the time it took to recover from the incident itself. So we have this metrics called RTO, RPO. This is a recovery time object. How long does it take to recover, and whether we can do it with data loss or not, like Amy mentioned. So those are the things that we are going to be measuring much more stringently, especially on services that have a design, like a by design failover to a different region or zone, and validate them in the environments. Finally, the final repair item that I want to talk about is documentation, right? We have a large number of services in Azure, and each service has a fair number of SKUs or offerings. Just like Amy was mentioning, SQL has offerings that are AZ resilient, that are not, that are like more dev test. And so we had to be really clear about the availability and the resiliency profile of each of these services. So it is really clear to the customers what they're using and what they're getting. And in terms of choosing the options in this, like whether I want an auto failover, whether I want a forced failover, all right? So those should be clear. So we are looking at the user experience, the documentation across all of this. One of the services that was not mentioned here that was impacted was Azure Site Recovery. So we're looking at like across the board at all the services and seeing that what we can do to not only like engineer and validate them better, but also document them better. So thank you.
Super. Thank you very much, Yunus. OK, I've taken some notes, and I just want to retell the story in my own words based on my notes. So I hope that's OK. So we had 4 chillers that had an issue at the moment. This is I'm looking at you with the mic at the moment. Heat wouldn't drop, so we had to shut down parts of our data center, untypically, but we had to do storage in this case. And that's when we started to recover our chillers. It took a while to do that. When we had to shut down storage clusters that were working OK, but in order to preserve heat, because we didn't want to pass a point of no return or extended recovery for storage. Then Brendan, you were telling the story about we had traffic going into the region. However, ARM being a highly resilient and highly globalized resilient service shouldn't have had impact, but because of a config issue, it meant that ARM wasn't optimized for zones. In that area, we rerouted or we drained traffic. We moved it over from Southeast Asia, which we took out of rotation. We put it into East Asia. However, it couldn't handle all the traffic that was coming in to perform those operations. As a result, customers using services in Southeast Asia would have had impact because the control plane was down, which meant they couldn't start, stop, scale, and so on. We had varying impact to SQL customers, as summarized by Amy. Thank you very much. And I really like the point that you spoke around availability versus data retention. And those are decisions that customers have to make in order to prioritize how they operate things. We had, for most customers using ZRS with SQL, they had 0 impact, except for a few areas where we saw pools of connections trying to happen all at once, and there was some exhaustion there. Yunus, and I'm wrapping up now, but you're telling our customers and our panel here that AZs do work. They are the right strategy for customers. It had exposed gaps in this, and we have learnings. There are repair items there that you're going to review all the foundational services. If I heard you correctly, you're going to walk the graph of dependencies every day because it's a very interconnected system, Azure and all the services that we have. The disaster recovery plans and our time when we want to fail over to a zone to make sure that those are short and so on. And lastly, of course, focus on documentation so that customers understand how they can leverage all the technology that exists to kind of make things work. Have I summarized things correctly, panel? Is there anything that I've either misspoken or that you would like to add or remove, or does that about capture it correctly?
That's good. Pretty good for opening statements. Super. Well, then great. Then we can get into some more of our kind of questions that were submitted onto the registration form. So since we ran through that in chronological order, Mike, I'll start with you here. A couple of questions about the data center impact. So the first one was a lot of questions about these chillers. So you talked to us about how the chillers went offline and we struggled to get them back offline. Two questions here. Chillers go offline in other data centers. Chillers go offline all the time. Could you talk to us about what we usually see happen when chillers are knocked offline and kind of why this was a little bit different?
Sure. And so, as David points out, chillers go offline. Normally, when a chiller goes offline, it has about a 15-minute restart cycle. With the data center design, we opted for something called a quick start or a rapid start. So this is an additional brain that will help that chiller come online quickly. Where the Southeast Asia data center went awry was that quick start or rapid start has a capacitive bank or an uninterruptible power supply. And when the sag happened, the quick start stayed up, but the chiller went down. When that chiller was returned or power returned to normal, the chiller said, hey, I was just interrupted. But the brain itself was like, no, I'm fine. And this is where that confusion came in, and it became a battle of the state of the chiller versus the brain. So that's what led to those chillers being locked out, and that's what led to the issue that we had to overcome on site.
Got it. That's helpful to contrast that. Now, you mentioned some of the OEM issues and how we were working with the equipment manufacturers to understand this. But we mentioned in the post-incident review that was ongoing. Is that still the case, where we still got some unanswered questions there?
So the simplest answer isn't always the best answer. Now, well, we believe we understand what happened here. We're continuing to partner with all teams involved, whether it's the original equipment manufacturer, the teams who came and looked at the logs, to continue to dig in. We want to make sure that ultimately no rock is left unturned. Once we have that information, we then share it out to our other data centers, places that have rapid restarts. Are we exposed to these events? Will we see, an interlock or a lockout event like we experienced in Southeast Asia? And our intent is to not experience that ever again. Run drills, expose, any opportunities we have both in training and with the equipment.
That's hugely helpful. And then the last question for you here. Well, we talked about in the post-incident review, we had a couple of these deliverables that we said by the end of February that we were going to do a couple of things. So I wanted to ask you for an update on, have we had any changes to our procedures or any additional training? Has that happened yet, or that depends on what we're waiting for?
So on site, where we were impacted, it has happened. Globally, we're looking at over 300 data centers checking to see what type of equipment we have. Do we have the equipment that we had in Southeast Asia? Do we have this configuration? If so, rinse and repeat the EOP, or emergency operations procedure. However, it'd be kind of silly of us to just stop at manufacturer, done. So now we're digging into where else do we have 2,000 ton plus chillers plus rapid starts of other makes. Do we see that same exposure? Are we working through it? If we do have rapid starts plus big chillers, do we have an EOP? Have we tested that EOP? We utilize in our data centers a system similar to the Federal Aviation Administration here in the United States. They call it field service bulletins. We call them technical service bulletins, where we share this information out to each of our data centers, our operations teams, and our, in some cases, our third-party service teams that come on and help our teams. This way, everybody is apprised of what has happened and how we can remediate if an event happens while either at the equipment or near the equipment. So it's not so simple as we're done at the end of February. We're continuing to look globally to make sure everybody is aware and prepared for this event, and then mitigating where we can.
Great. That's an even better answer than check. It's a work in progress. We're still getting better and better. That's great.
So, Brendan, I have a question for you. ARM underpins everything. So when a customer or even when a service sends a request to ARM to go and do something, there's retry built in. There's retry logic built in, just in case that fails. Is that retry logic on is a customer supposed to program that? Is that a first-party service? Does ARM handle the retry? Who's responsible for the retry logic to make sure things just don't time out and go poof and we lose it?
Well, at the end of the day, ARM is it's an HTTP-based service, right? So it responds in the same way any other web server you would expect a web server to respond. And although it's generally very, very highly available, it's not perfect. And so even in steady state operation, you can expect to occasionally see a 500 error or some other sort of problem that happens in the network, either between ARM and the constituent services in Azure, or even between your client and Azure. The internet is a wild place at times. And so we think that the best practice is for every client to have retry built into the HTTP requests that they send to ARM. And in fact, ARM was designed with this idea of idempotency in mind. And the idea behind idempotency is that if a request happens to be sent multiple times, let's say you send the request, it times out, you're not sure whether it arrived or not, ARM has a guarantee in it that if you resend the exact same request, you don't get 2 virtual machines or 2 databases. If you send the same request multiple times, you still only get 1 resource, which means it's safe to retry a create or a delete or an update or any other operation to ARM. And so our general practices follow the same practices as HTTP anywhere. And if we return a 500 error to you, or if something in the middle returns a 500 error to you, that's an error that you should retry. Now, of course, sometimes errors happen and you don't want to immediately retry. Maybe you want to wait a period of time before it comes back. And so we also supply a retry after header that kind of gives you a hint of like how long you maybe should wait before you retry. And those 2 things together, I think, form the best practices actually for both the first parties and the third parties. And that extends even actually to some services that I own. We got some feedback from people using the Azure Web Portal, which is another one of my services, that certain operations in the web portal, let's say to delete a disk, didn't succeed, and the portal just gave them an error, and they had to go and click the button again, and then it succeeded. I think the portal should actually take that request of pressing a button to delete a disk and actually sort of take it for you and take responsibility and do some retry for you until it actually succeeds. And so we're taking those lessons into my services, and we're working with a bunch of other Azure services to ensure that they have appropriate retries in all of the right places.
Super. Thanks, Brendan. I actually had a follow-up question for you, Brendan, while we're talking about ARM here. You explained the difference when we when we took Southeast Asia out of rotation, that East Asia kind of struggled to keep up with the traffic. A few of our customers were asking, is it possible that that same kind of traffic pattern exists in other paired regions or other regions around the world? And is that something we can test for and kind of be more proactive about?
Yeah, so I think there's 2 pieces to this. One is that actually using DNS load balancing is kind of an old approach to load balancing. And quite frankly, the ARM team is undertaking a repair item to move to L7-based load balancing instead of DNS-based load balancing, because at that point, then you have control at a request-by-request basis, and you can say, East Asia can only satisfy 5,000 requests. We'll spill the rest of them maybe to Australia, maybe to Korea, or wherever else it happens to be. That's sort of the beauty of being a global service. So that's one piece of it, which is that we should have had better control over our traffic than we did. And I think that the other piece that you're getting at is that sorry, my mind is blanking. The question that you asked.
Yeah, could that happen again? Are there other paired regions?
Right. The other issue that happened that was particular to the Southeast Asia region has more to do with network topology. Okay. So when you do DNS-based load balancing, what the DNS does is it has a geo map, and it says, oh, your IP address, we think you're in this particular location. We're going to send you to this particular data center. That means that because of the network topology of Asia, you tend to send all of the traffic to a particular location. If, for example, you had a failure in the middle of the United States, well, some traffic would go to the West Coast, some traffic would go to the East Coast, some might go up into Canada. it is less likely that it would happen in those locations, but truly getting to L7-based balancing is the right answer.
Great, and that sounds like a longer-term improvement, but something that we're already working on. Very good. Eunice, question for you here. You gave us a run-through of kind of the different zonal repair items in terms of post-incident reviews. A few of our customers are asking, could you just give us a bit more context on how we test and drill zones? We'd love to understand that. And then a couple of bonus questions here. People are asking about Azure Chaos Studio and fault injection. Yes. We recommend our customers do that. Is that something we're looking at for first-party services as well?
Yeah, absolutely. Yeah, I mean, we test zonal resiliency with a pretty extensive kind of a validation setup. So we have, to start with, we have pre-production regions that kind of mimic our production regions. This is the canary and the pilot regions. So there we have a variety of tests that happen. We have what we call zone down drills, where we hard power down a zone and create different kind of fault mechanisms, and then have a variety of both synthetics and actual customer traffic going into canary, which we observe and watch and see for the failure points that happen. So that's one class of testing. Another class of testing that happens is basically when we do the zone down drill, we cannot get all kinds of faults. It's kind of, we hit the main ones. But to get the more finer kinds of faults, we use Chaos Studio. Yeah, it's exactly the product that you see on Azure website. So we use the Chaos Studio internally itself. Now, Chaos Studio is something that did not have as much capability to inject zone down kind of faults. It had other ways of faults like IO stalls or network interruption. It has those capabilities, but it did not have the zone down capabilities. But Chaos Studio team is working on that to increase the coverage for zone down suite of tests. So we are going to use that to inject faults into our Azure foundational services to then see how that behaves when such faults happen. But then there are other kinds of testing too that I want to call attention to. So there is cases, all of our services are very distributed and they're partitioned services, if you will, right? So even within a region and sometimes even within a zone, they are further partitioned into what's called partitions and cells and things like that. So what we can see is sometimes if a certain partition or a group of partitions get overloaded, that unless those resources are correctly governed, that impact can spread beyond those partitions, and then can actually spread to like a zone level or beyond, right? So these are the things that we are paying more attention to as well, to see that we can isolate the failure at different levels, like region, zone, partition. These are like decreasing levels, but the closer that we can isolate a fault to, the closer to the point where the fault happened and not let it spill out, the better off we are. So all of these are in the scope of the testing that we're doing. Yeah.
Great to hear.
Super, and I imagine that first-party services are using Chaos Studio. That's something that our customers can leverage as well. They can create zone-down scenarios to test as well.
Absolutely, absolutely. Whatever we're doing for first parties here, that's the same product for Chaos Studio. That's also shipping for everyone. So absolutely all of our customers will have the same capabilities that we are utilizing internally.
That's cool that we can run the same drills. Tom, can I turn my attention to you? Many customers would have had different, their storage accounts configured differently. Some with ZRS, some with GRS, LRS. Did everything work as designed for storage customers as we brought storage down?
And not everyone's familiar with those acronyms. Sorry. So could you explain ZRS, LRS, GRS for us as well?
Right. So we have three main levels of storage resiliency. We have LRS, locally redundant storage. In that case, there's only one cluster, one storage scale unit has a copy of the data. In that case, there's no redundancy, right? So in this case, LRS accounts that were in the affected portion of the affected zone, where we'd shut hardware down, those would have been hard down, which is expected. We have ZRS, where we have kind of cross-zone replication. And we did actually shut down a portion of the ZRS clusters in this region to help with power and heat. And there was no impact to the ZRS accounts during this outage, so that worked as designed. And also GRS is a little more nuanced. So GRS is geo-replicated storage or geo-redundant storage, I'm not sure which. And in that case, the accounts are replicated out to a scale unit in a different geo region. There's a subtlety here because we have two types of failover. We have what's called customer managed failover and Microsoft managed failover. And customer managed failover is a customer decision and it's account granularity. Microsoft managed failover is not account level. It's a decision that we would have to make to fail over a whole storage scale unit. GRS replication is asynchronous, so whenever you do an unplanned failover, there is, the possibility of losing some data that has not yet replicated to the other side. For that reason, and for us, Microsoft Managed Failover is a whole scale unit with thousands of customers on it. That's a decision that we would not really make for those customers unless we had the building has burned to the ground or something, because by doing so, we would be deciding to cause some data loss for customers with Microsoft Managed Failover accounts. Now, the problem here, everything worked as designed. The documentation is a bit lacking, is kind of what's come through. It's not very clear in the documentation, frankly, that if you have a classic account, one of the limitations is if you have a classic account as opposed to an ARM account, you cannot do customer managed failover. And we don't have the capability either to fail that account over for you unless we decide to fail over the whole scale unit, which is not something we decided to do in this case. So the documentation is very unclear on two things. One is the limitation on classic accounts, and the other is it's a bit ambiguous as to, is Microsoft Managed Failover, can we fail over your account for you on request? No, we can't. And that's not called out well enough in the documentation. So it worked, but there were some customers who were unpleasantly surprised, compared to what they'd expected from reading the docs.
Thank you for explaining that nuance to us, and that's as good a learning as some of the more technical ones here. We need to get better at explaining that to customers and up that documentation. That's great. Now I'm gonna turn my attention to my co-host here, Sammy. Since you run our incident communications team, as I was going through the feedback here, we've had a bunch of customers who are asking about the updates they received. So it looks like we started initially, we were just providing targeted communications within the portal into Service Health. At some point, it was broad enough that we went to the status page. Could you just talk us through kind of how do you feel the communications went and what we could improve?
When outages happen, customers don't have much to kind of pick up from Microsoft. Support really don't have any extra nuggets. Account teams don't have any extra information. And so it's the communications that we send that customers are relying on. In this case, what happened, as you said, we began with a very targeted shutdown of some storage accounts, and we communicated to those customers immediately. And so they kind of understood. And I use Eunice's line there, as we walk the graph of dependencies there, and other services that are leveraging those storage accounts started to see impact, and those services started to experience some sort of degradation, and as ARM kind of kicked in and services became unable to scale up, scale down, create and delete, more and more services raised their hand and said, hey, we're impacted. We decided to communicate broadly on our status page, which we don't like doing because it doesn't allow customers to understand if they really are impacted or if they're not, but we communicated on the status page because impact was broad. Typically, we like to offer ETAs, and it's always tricky to do it. Our general position is to say, we're okay to offer an ETA, and it's okay to be wrong, but we're gonna offer you an ETA anyway and see what's going on. I think where we missed it here is that we should have worked closely with the data center team to understand, hey, if we think it's going to take 2 hours, we need to factor in an additional 5 hours or 6 hours, whatever the time is, to bring the data center back to a cooling temperature. So we could have told our customers, we don't have a time at the moment, but it's at least 7 hours away. And at least that piece of information would have armed customers to say they can either have their own BCDR, they can go out, they can fail over, whatever they need to do, they need to do. So I think we have learnings in our comm space. We wanted to provide as much information as we can. Obviously, during the fog of war, it's tricky to get, but that's a takeaway from us, that we need to be more transparent and more forthcoming with our information and bake in ETAs even when we don't have an ETA, if that makes sense.
Got it. No, that's really helpful there. I see we've just hit the hour because our visualizations are changing behind us, so it must be 6 o'clock here in Redmond. That we are about to run out of time here. Now we're going to leave the ongoing Q&A open if people want to get their last questions in, but here's my final question to the panel here, and we'll just do a quick lightning round for everyone. Whenever we do these post-incident reviews, we get two different kinds of feedback. We get people who say, that was way too technical, I didn't understand it. And we get feedback that says, that wasn't technical enough, give me more detail. But we've gone into, I think, a fair amount of detail today on some of the specifics, but I know there are folks watching who are maybe of a less technical background. So I just wanted to ask for your kind of key takeaway or your one big learning from each of your service teams. If customers forget what happened over the last 45 minutes that we've been talking, what's the one thing that they should remember? And so I'll just fly through in chronological order, starting with Mike.
Thank you. For me, outages happen at a physical layer. We need to be prepared, A, in our data centers, and B, with our services broadly, to be able to ride through, move, or migrate away from those outages and keep our customers up and operational.
Great. Tom, from storage?
Yeah, I think for me, it's around the making sure we really clearly, crisply communicate what options are available for the different storage types, right? We can't have things that are confusing that lead people to make a choice that when there's an outage, they're not getting the protection they expected.
Right, make that decision in advance. Yeah, I like it. Brendan?
Yeah, I think for me, it's that, errors are going to happen, and making sure that your software is ready for errors that can be recovered from, for partial degradations, make sure our software is ready to try a couple times to make sure that it gets through.
Great. And more?
Yeah, for me, it's to reiterate that we are committed to zones as an availability strategy, and we are working hard to address the gaps, and we hope it'll be better than what it's been in the past.
Great, thank you, Eunice.
Super. And Amy, I don't want to forget you sitting there. Are there any key takeaways that we should gone from SQL?
Yeah, in addition to what everyone has said, is defense in depth. Everything can fail. There are lots of unexpected and unusual failures. Can be in data center, can be in compute, can be in storage, can be in service fabric, can be in SQL itself. So defense in depth, expect the unexpected, and use drill, a lot of the simulation to uncover a lot of those unexpected.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us. Thanks.